Hey everyone, it's Guilherme. In this series, we are going to create a base or a prototype for a puzzle game like Sokoban. We are going to be covering player movement, pushing boxes, both grid-based and physics-based, and also pressing platforms with those boxes. This is going to be a code along tutorial, so if you like to follow along, you're gonna have to download Godot version 3.1. Before getting started, head on to the repository of the Kickstarter and clone it or download it into your machine. And here you're going to find the puzzle game folder, and inside you're going to see two new folders. One is for the end state of the game, so if you like to play around with it, feel free to. But if you're going to follow along, we're going to start from the start folder. This contains the assets that we're going to need inside of the game, and also a map that has already been set up for us. Now, after downloading it into your machine and importing the project into Godot, you're going to find this. All we have here in this starting project are some assets that we are going to use to create our game, and also a pre-created level with a tile set for us. And in case you want to, feel free to customize this map, but in my case I'm going to leave it as is. So let's begin by creating our player with our game selected. I'm going to click here to add a new node, and I'm going to search for kinematic body 2D. And I'm already going to rename this kinematic body to player. We're going to need an animated sprite here because we're going to animate our player, and also a collision shape. Now let's select our animated sprite and add new sprite frames to it. Click on it and open editor. I am already going to rename this default animation to idle. Now we can go to our assets folder and expand our sprites folder. And under the player folder, we're going to find several different sprites that we're going to use to animate our player. And by the way, all of the art that we are using here is from Kenny's Sokoban pack. He created awesome arts that you can use for free. For the idle animation, we are only going to need the player underscore 5. Now we are going to need 4 animations, each one for each direction that our player is going to be able to walk to. So let's begin with the down animation. Here we're going to need sprite 6 and 7. And the speed we can leave as a default of 5 frames per second. Now let's create our left animation. In this case, it's going to be player 21 and 22. Now up, which is going to be player 9 and 10. And for the right direction, we're going to need frames 18 and 19. With this, we can zoom in into our player and add a collision shape that resembles the shape of our player. So let's select our collision shape 2D. And on the shape, we're going to select a rectangle shape 2D. And we can zoom in and activate pixel snap. This way, it's easier for us to change the size of our collision shape. And now we're going to create something that hopefully resembles the shape of our sprite. Perfect. Now let's right click on top of our player. And I just realized that I named it incorrectly. And we are going to save branch as scene inside of our player folder with the name of player.tscn. Now we can open that scene, and we are going to add a new script to it with our player selected. In the template, we can change from default to empty, and we can leave the default path and click on create. Now inside here, we are going to need a reference to our animated sprite because we are going to want to update our animation if our player is either facing up, down, left, or right, or if he's stopped. So let's get a reference to that by creating a new variable. It's going to be of type animated sprite, and let's reach out to our animated sprite. We're also going to need 2 exported variables. One is for the movement speed of our player, and the other one is going to be the push speed of our player. This is going to be the speed that we are going to move at when we are pushing boxes. Because we're dealing with a kinematic body 2D, we're going to have to use the physics process to check for inputs and move our player accordingly. I'll begin by creating a new motion variable. It's going to be a vector 2. And the value of x and y is going to be determined by our inputs. These inputs have already been created. If you go to project settings and switch to the input tab and scroll all the way to the bottom, you'll see that we have move up, down, left, and right. You can customize this if you want, in case you want to use different keys or if you have a gamepad. In my case, I'm going to leave with WASD. So for the value of our motion x, the x value is the value of our horizontal movement, and it's going to be equal to input.getActionStrength. This way we can have floating values if we are using a gamepad. Here we're going to select move right minus the value of input dot get action strength move left. As for the y value of our motion, it's almost going to be the same, but for the first argument, we're going to, instead of check for inputs in move right, we're going to check for move down, and the second one is going to be move up. Right after checking for inputs, we are going to call a function that we have not yet created, which is going to be called update animation, and we're going to pass to it our motion. This way we can determine which animation to play based on the values of our motion. Godot is already complaining that we haven't created this function yet, so let's create it real quickly. Down here, we are going to expect a motion, which is going to be of type vector2, and we're going to return void, and here we can just pass as of now. Alright, so after calling update animation, we are going to move and slide our character. The linear velocity is going to be our normalized motion multiplied by our move speed. And because we're dealing with a top-down game, our floor normal is going to be a vector2. Now let's create our update animation function. We will begin by creating a variable which is going to hold the name of the animation that we want to play. We are always going to assign it to be equal to idle. And now we're going to do a few checks. In the case that our motion x is greater than 0, our animation is going to be equal to right. If not, we're going to check if our motion.x is lesser than 0, then our animation is going to be equal to left. If not, we're going to check if our motion.y is lesser than 0. This means that we are going up, so our animation is going to be equal to up. And if not, we're going to check our motion.y is greater than 0. And if that's the case, our animation is going to be equal to down. Now, if you saw previously, our animations are always in loop, so we don't have to keep playing them in case we are playing the same animation. If we do that, what's going to happen is that our animation in every frame is going to start from the beginning, and we're never going to see it finished. So it's going to give us some weird behavior, and because of that, we have to, later, after deciding which animation we're going to play, we're going to reach out to our animated sprite and check if the animation that is currently being played is different than the animation that we decided that we're going to play here. And if that's the case, we are going to reach out to our animated sprite and then play this animation. We can now save our player script. And if we go to our game scene and go back to the 2D view, and I'm going to move the player here to the middle of the game and press F5 to play our game. We now have a player that can walk around and it's correctly animated. Now we're going to create our physics box, and because we're going to have two boxes in this game, as I said before, one is physics based and the other one is going to be grid based, we can use inheritance to both reuse code and also the scene instead of having to create them all from scratch. So that's what we're going to do. So let's create a new scene by clicking on scene and new scene. This is going to be a kinematic body, so I can click on custom node and search for kinematic body. And I'm going to rename this kinematic body to box. Here we're going to have a sprite, so we can search for it, and also a collision shape for our kinematic body. Alright, with the sprite selected, let's add a texture to it by going to our assets and looking inside of our sprites. Here we have a tile sheet that we can just drag and drop into our texture. And we're going to activate the region by going on the region and clicking enable. This way we can go down here and click on texture region. I'm going to expand this menu. The snap mode, I'm going to set it to grid snap. And the size of the grid is going to be 64 by 64 pixels. You can choose any box that you want to. In my case, I'm going to select this red one on the top here. Once you find the box that you want, you can just drag your cursor. And because we're using grid snap, it's going to correctly select the box. Now we can close down this menu. And you'll notice that we have a box here. Now I'm going to zoom in into the box and select the collision shape. The shape is going to be a rectangle shape 2D. And instead of dealing with the handles and trying to create the shape correctly, because we know that this sprite is 64 by 64, I'm going to set the size of the shape to be 31 by 31. This is due to the fact that we had run into some bugs if our extents were 32 by 32. This way it would cover the whole box. And we're going to see this bug when we start to create our grid-based box, but for now, let's keep it at 31 by 31, because it's going to save us some trouble in the future. Now we can select our box and save the scene inside of our world into props, and we're going to leave it inside of this folder right here. Click on save. And with our box selected, we're going to add a new script to it, which is going to be called box, and we can click on create. Now this box is just going to serve to us as an interface or a boilerplate, which is going to be then implemented by other boxes, both the grid-based and the physics-based box. And as they're going to inherit it, we're going to give it a class name, which is going to be box. And here we're going to define a new function, which is going to be then implemented by these other two boxes, which is going to be called push. We're going to receive as an argument a velocity, which is going to be a vector2. It's going to return nothing, so return type is going to be void. And because this box, again, is going to be inherited and implemented by the other two boxes, what we're going to do here is just print that push was not implemented in, and we're going to pass the file name here. This way, if we later decide to implement a new box and we inherit from the box and we forgot to implement push, we're going to know that we forgot to implement something, and we can go to this file and implement the function. All right, now that we have our box created, we can create a new inherited scene by going to scene, inherited scene. Godot is already going to select box to us because we have this scene open, so we can click on open, and we're going to rename this box to be physics box. I'm going to remove the script from the physics box because we're going to implement our own custom script to the physics box. So before creating this script, I'm going to save our scene inside of the physics box folder. I'm going to click on save. Now we can already attach a new script to our physics box. You notice that if I try to click here, nothing's going to happen. This is probably a bug on Godot version 3.1 beta. So I'm going to select the sprite and select the physics box once again and click on the attach script. Now the menu is going to open and I'm going to leave everything as default and click on create. Now this physics box is going to extend from our box that we created before. The class name is going to be physics box. Now we have to implement the push function that we created on our box. So let's create it. And again, we're going to receive a velocity. It's going to be a vector2 and turn void. And simply what we're going to do in our physics box is call move and slide, because this box is a kinematic body 2D with the velocity. And once again, a vector2 as our floor vector. All right, now we can save this scene, go back to our game. I'm going to press F1 to go back to the 2D view. And with the level selected, I'm going to add a new child to it, but in this case, it's going to be a scene. And we can select our physics box and move it somewhere around here near our player. If we play the game now, you notice that we are not going to be able to move the box because we haven't yet implemented this in our player. So if I move closer to the box and try to push it, nothing's going to happen. All right, let's go back to our game. And now I'm going to open the player script. Before implementing the functionality of pushing the box, I'm just going to fix a typo here in the animation. We're missing a column here. Now, to implement the functionality of pushing boxes, what we're going to do is check in every frame if we are colliding with something. And if we are colliding with something, we're then going to check if we are colliding with a box. If it is a box, we're only going to push it if we're moving in a direction which is either horizontal or vertical. We don't want to push our box if we're moving diagonally, so we're also going to have to create some checks because of that. Now let's stop talking and implement this functionality. Here, right after we move, we are going to check if our slide count is greater than 0. This means that we are colliding with something, and if that's the case, we're going to call a function that we're going to create now. It's going to be called check box collision. And here we're going to pass the motion, because again, we have to check if we are moving diagonally or only vertically or horizontally. And right after our update animation function, I'm going to create a new function. It's going to be called checkbox collision. Again, we are going to receive a motion. It's going to be a vector2, and we're going to return void. Now to check if we are moving diagonally, what we're going to do is use our motion, and here we have x and y, and if the sum of the x value and the y value is greater than 1, this means that we are trying to move in a diagonal direction. So let's do this by creating a if statement, and here we have to use the ABS function, which is going to return to us the absolute value of whatever we pass to it, because if we're moving to the left or up, these values are going to be negative. We might get a value that is lesser than 1, but in reality, we were moving in a diagonal direction. So to prevent that from happening, let's call ABS motion.x plus ABS motion.y. And if that's greater than 1, we are going to return from our function. Now to determine if we are colliding with a box, we're going to create a new variable, which we are going to call box. And we are going to call a function that is provided to us by the kinematic body 2D, which is get slide collision. Here we have to pass to it an index because we might be colliding with more than just one body. In this case, we're always going to check for the first body that we are colliding with. And we're going to reach out to its collider, which is the object itself that is being collided with our player. And we're going to cast it to a box. If this casting fails, this means that we are not colliding with a box and we don't have to do anything. So we are going to check if box. This means that if this variable is not null, because if this fails, we're going to receive a null value in our box. Now we know that this is in fact a box, so we can call the push function that we have created in our box. And here we are going to use the push speed that we exported before times our motion. Now we can already save our game and test our box. Now if I run closer to the box, you'll see that we are now pushing it. And even if we try to, we cannot push it in a diagonal direction. Alright, now that we have our player working and also a box to push, what we're going to implement now is a platform that our player can push boxes onto, which is going to be then pushed like a button is. We're not going to really add functionality to this platform. What we mean by that is that we're not going to make this platform do anything. We're just going to make it usable so you can then later on add functionality to it. For instance, making when the platform is pressed, a door opens or something of this sort, as the objective of this tutorial is just to create a simple prototype that you can then later on build upon. Alright, so now that we know what we're going to do, let's create a new scene by going to scene, new scene. The platform is going to be an area 2D, so we can search for it, double click, and we're going to rename it to red platform, in my case, because I'm going to create a red platform. We are going to need an animated sprite, which is going to hold an animation or just one sprite for when our platform is pressed and one for when it's not pressed. And because we're dealing with an area 2D, we are also going to need a collision shape. Alright, now let's select our animated sprite and create a new sprite frames to it and open the editor. Here we're going to have two animations. One is going to be called down, or when the platform is pressed, and the other one is going to be called up. For the down animation, we're going to go to the assets folder, and inside sprites and inside platforms, we're going to find the crate 33. This is when the platform is pressed, so we can just drag it and drop inside of our down animation, and crate 38 when it's up. Now I'm going to zoom in into our platform, select our collision shape, and the shape for this collision shape is going to be a rectangle shape 2D. And we're not going to change the size of our rectangle shape because when we are moving a box on top of the platform, we don't want it to be pressed just as we touch the platform. We actually want our box to be somewhat in the middle of the platform. And by having a really small collision shape like this one, this is going to be handled by us without much effort. And just before creating a script to our red platform, let's select our animated sprite. And the correct animation that we want to display here at the beginning of the game is going to be the up state of our platform. Alright, now we can save this scene by pressing Ctrl S. I'm going to go up one level, and I'm going to save it on the props folder of our world folder. With the red platform selected, I'm going to attach a new script to it, and I'm just going to change the name from red platform to platform, and I'm going to click on create. We are going to need a reference to our animated sprite, so let's grab this by creating a onReady var. It's going to be of type animated sprite, and let's grab that reference. Alright, here we're going to have two signals that are going to be emitted when the platform is either pressed or unpressed, and that's what I mean before saying that you can then use this to implement the functionality that you want. On the ready function, we are going to connect to our body enter signal. It's a function called onBodyEntered. And we're going to do the same with body exited. The function is going to be called onBodyExited. Now we can create both of those functions. So I'm going to just copy their names and create this function. Here we're going to receive a body which is going to be of type physics body 2D. By the way, you can name this body parameter here anything that you want. I'm just going to name it body to keep it the same as what would happen if you decided to connect the signals using the editor. And this function is going to be of type void. Now we have to check what body entered on our area 2D. And remember, we only want our platform to go down if this body is a box. So we're going to check if this is not. a box. And if that's the case, we're going to return from this function. If not, this means that we are colliding with a box. And because we have used inheritance, any box that we create, be it a grid box or a physics box, is going to be nonetheless a box. We can get away with just checking this instead of having to check for every type of box that we have in our game. Now that we know that indeed a box entered in our RHD, we're going to reach out to our animated sprite and play the down animation and emit the signal that we were pressed. Now we can copy this function because the body of our body exited function is going to be pretty much the same, and paste it here. Now I'm going to rename the function to body exited. And here, instead of playing down, we're going to play up. And instead of emitting pressed, we are going to emit unpressed. Now we can already save our scene, go back to our game, go back to the 2D view, and with our level selected, let's add a new child to it, which is going to be our red platform, and let's place it somewhere around here. And now if we play our game and try to put our box on top of our platform, you notice that the functionality is working, but we have some problem with our Z indexes here. So let's fix that by going back to our editor and open our box scene. And with the box selected, we're going to go to the Z index on the inspector and set the Z index to be 1. And one last thing that we have to do is go back to our game scene, select our physics box, and here we have to go back to the value of our scene by clicking on this icon. Now our Z index is going to be fixed, and every other box that we create is going to be fixed because it is fixed on the main scene of our boxes. Now we can press F5 to play our game, and as you can see, it's now fixed. We now already have a working prototype, but in the next video, we are going to create a grid-based box in case that's what you want to implement in your game. Again, the whole project is available in GitHub. If you have any questions, feel free to leave them in the comment section, and I'll see you in the next video.